So whether your MS be a resource or Power BI a resource, no matter. First, you need to have knowledge on data warehouse fundamentals. Second one, you need to have knowledge on data model fundamentals. Good knowledge on the first and good knowledge on the second compulsory. Okay, board. And in your material, you will find the data model details and warehousing details. You have theory and you have FAQs. 100% questions in interview from these two topics from our material only. Read the theory, read the practical, sorry, FAQs in our material to answer 100% interview. Not just reading it, try to understand the beautiness of subject. In IT industry, wherever you go, whenever you work strongly with a particular tool or process or component, this knowledge will chase you. Without this knowledge, you cannot establish a nice career in IT, especially business intelligence, artificial intelligence, and data science level. So strong knowledge is compulsory. And we are done already. We already done warehousing fundamentals. This is a time we need to walk through model fundamentals. Then what is model and how do you work with it? So these are data warehousing fundamental FAQs. And now we are going to model fundamentals. So data model, simply data arrangement, data plan. So if your data arrangement, data plan is good, then only you can construct a beautiful database. And the database is suitable for your day-to-day data storage and day-to-day retrieval as well. Day-to-day retrieval. And I explained you this picture many times. I explained this picture many times. Correct? This is a database. This is also database. But here the database size is less. And the database suitable for transaction operations. What do you mean by transactional? Their support for observing the data. How many tickets available at present for a movie? You can see. You can book a ticket. Booking a ticket is front-end operation. Back-end is insertion. And you can modify a ticket. You can cancel the ticket. These are all suitable. These are all applied on this database. Whereas this database size is more, warehouse level, and it's not suitable for these kind of operations. And we are gathering the data for analysis. For analysis in the sense, we use only select statement. Which statement? So we need to construct this database in such a way where you can apply all these operations easily. You need to construct this database where it is suitable to perform fast retrieval, better retrieval. Our objects are different, database is different, and our objectives also different. That is why to implement these operations, here we go for a model called normalized model. And here we go for a model called denormalized model. The normalization model basic protocols. First one, don't maintain duplicates in any table more and more. Not maintain. Second one, try to have multiple tables, small tables by providing primary foreign key relationships. Try to have as many as child tables and simple tables. Child tables and simple tables. First one, no duplicates. Second one, many small tables with keys. With keys. These are understandable statements, but technically, normal form 1, 2, 3, Boise got normal form 4, 5, 6. But almost all the company they are stopping their process with either BCNF or till third normal form. Till third normal form. And normal form 0 operation is different. Normal form 0 operation is so normal form 0, 1, 2, 3, 4, 5, 6. Total 6 normal forms available at present. But all companies trying to ensure 3 are till BCNF as part of normalization. But we don't bother in the warehouse level regarding normal forms, normalization. That is why I haven't explained, even my Sivas or other trainers, they won't explain about normalization. You need to know about denormalization, where denormalization is suitable for duplicate storing. Duplicates loading, duplicates loading, and reducing number of keys. Keys will help you to provide uniqueness data and to provide less undegraded data, so that more and more unique entities you will find it, your system will perform operations very quickly. But whereas warehouse level, unless you store duplicate, you cannot analyze. Example, when I move to 100 locations, the difference between daily system and warehouse system I'm explaining, concentrate. This is your requirement. Vinay, Hyderabad, Vinay, UK, Vinay, Mumbai, Vinay, Chennai. Some dates and available. These are your records. Warehouse level, unless you store like this, you cannot answer where is Vinay right now, where he was last 2 months, and what was his initial location. You can't answer. Correct? But daily level, this is not the case. In case you have a situation like this, assume. Anyway, it will not support duplicate, so the team maintains like this. This table they consider like customer table, and they will mention here customer ID, customer name, and this ID is 1, name is Vinay, and they will separate into one more table. This is customer location table, customer ID, location ID, they will maintain, and again the locations in one more table. So location ID, location name. So example 1 or something, H1 Hyderabad, M1 Mumbai. Whereas this table level they maintain like this: 1 location ID, M1, H1, and again second record, do duplicates in this area, 2 or 1 M1 and 1 some R1, something like this. Because one customer can go to multiple locations, or multiple locations can be used by multiple people. So simply many-to-many relationship we have. What kind of relationship? And always a many-to-many relationship require one intermediate table, and that is bridge table. Which table? So this is customer table, this is location table, this is the bridge table. Here you have only unique entities. In the previous batch, I haven't explained many-to-many. Now I'm explaining the reason almost all people concentrating on many-to-many relationship. If you go for interview and you kept AS in your resume, they'll ask you, can we implement many-to-many relationship in multidimensional model? And how? Can we implement many-to-many relationship in tabular model? How? Tabular model, many-to-many not possible. Only multidimensional model possible. Only multidimensional model possible. Fine, okay. Click this. This is unique entities. And this is called bridge table. When we work with Power BI, when we work with tabular model, when we work with multidimensional model, tabular way not possible, but multidimensional Power BI compulsory we need to focus on this. Minute to minute will give you more analysis, better analysis, more and better. Because here you have unique entities, no need to bother. Here you have unique entities, no need to bother. Just key references available here, you can play with this. Yes, simple playing, simple. And total how many types of relationships we have? 3. One is one-to-one, one-to-many. Second, next one. Can you tell me an example between one-to-one? One customer having one Aadhaar number, or one customer belong to one department. This is one-to-one. What about one-to-many? One customer may travel to multiple locations. This is one-to-many. What about many-to-many? Multiple customers, multiple locations. This is many-to-many. Both vice versa like this. So normally we present like this: one-to-one. This is one-to-one. One-to-many. One-to. When it comes to end, this is a presentation. Many presentation. Now many-to-many. Location table. Assume location table is right hand side, and customer table left hand side. This is many-to-many. This is the presentation of once again entity relationships, one-to-one, one-to-many. Sir, what about bridge table? Bridge tables usually presented with this. Got it? So these kind of relationships usually established in daily systems and construct a normalized database. Whereas warehousing level, that architecture, the structuring, not recommended and not suitable also, because our objective is analysis with more duplicates. So our framing is different. Now I'm going to explain, you concentrate. So what is data model? That's okay. This is a picture. So entity relationship for daily people and dimensional modeling for warehousing people. And what kind of terminology we use? Entity, attribute, primary key, foreign key. And here different. Okay. Let me explain a generic situation. This is a location table or sales table. Assume sales table. It is storing product ID, product name, product sales, product total sales, product average sales. Sales table. ID, name, sales, total sales, average sales. And usually this is a primary key. What do you call this? And remaining is data. Primary key. This kind of information we will have in OLTP systems. We have in the OLTP. Whereas OLAP level, we don't maintain like this. What we do is the complete product information will move to one area, product table, and only textual data will maintain like product ID, product name. And this is as usual primary key. And ID and name, although this is numeric, concentrate, although this is numeric, but we don't use it for aggregate operations. Which operations? Aggregate. So I'm writing a small definition. Textual attribute. Textual attribute does not support aggregate operations like sum, average, min, max, etc. Whereas measurable attribute Measurable attribute support aggregate operation like sum, average, and all. That is the difference. We never use ID for summing, averaging, etc. So we call it as textual. Although the data type is numeric, still we consider as textual. Although the data type is numeric, still we consider as textual. And this is also a textual one. Is this clear? Any questions? No. Now, so we'll separate. And in case organization data you have, now we'll place organization as a separate table. War ID, war name, etc. And this is the primary key. This is the primary key. And what about the information, sir? Business information, we maintain one more table, fact table. And here the product ID will maintain, organization ID will maintain, and we will maintain the respective sales, product sales, if it is organization sales, something like this. And this is a central table. If you observe, automatic menu to menu available, correct or not? Multiple tables on bridge table. Multiple tables and bridge table. And but here, this kind of more and more duplicates will maintain. Product ID 1, organization ID 1, sales, product sales 2000, product organization sales 3000. For individual value, not total sales. And product ID 2, organization ID 1, product sales 3000, and this sales 4000. This is the way data maintained. And the normal table converted into two tables. One is business data table, measurable table, second one textual table. So this textual attribute is called dimension. And wherever you maintain these dimensions, the table is called dimension table. If you listen first time, a bit confusion and different terminology. If you watch the video again, it simplifies your understanding. So watch it again. This is compulsory if you want to stay tuned with warehousing or BA. And whatever it may be, you're reporting or ETL you're working on. No matter. Strong knowledge, good knowledge of this is compulsory. And this is dimension. And organization data you have, so organization dimension, organization. Focus, I will ask you questions on this. And these are foreign keys. This is primary key. So this is foreign key. This is foreign key of the table. And but all together, it will construct a key called composite primary key. And this is measurable part. This is a measure, this is a measure. So we call it as measure group area. Which area? And simply some people call it as fact table. Altogether, since sales data you are storing here, sales fact table. Sales data you are storing here, so sales fact table. Now, let me explain you the table's information. Day-to-day level, textual and measurable data, single area. Whereas analysis level, textual in one area, measurable in one area. But the measurable area references textual data. And that is called foreign key area. The actual measurable part area is measure group area. And these tables are called dimension tables. And this table is called fact table. Dimension table, now features. Point 1. Master table, isn't it? Because primary key, reference foreign key. This is master table and this is child table. I will write some differences. You please read it loudly. This is dimension, this is fact table. This is master. What about this? Only textual columns. And here? Which has primary keys more. What about this? Correct. And dimension table level, columns more. Fact table level, columns less. Now you can ask me, sir, in this situation, we have more columns in the fact table. Then how come you say fact table columns are less? Usually, text tables are descriptive tables. So more information for a particular product, ID, name, size, color, format, area, many things will maintain. So more. Now I mentioned one or two, but in real time, more and more come into the picture. Take this mobile, including cover, everything, lot of information, descriptive information. So number of columns more, columns less in fact table. But here rows less. What are less? And what about here? Daily business data goes to fact table, not dimension. So dimension loading is rare load. For example, your company product table you want to load. If your company manufacturing 10 products, 10 product data available in the product table. If you decide to manufacture some more products, rarely we take the decision. Month, quarterly, half yearly, year wise we will take the decision. So that time only the table change will come. Suresh, Anand, so dimension table loading happen according to your business change. But fact table it's not like that. Regularly the product sale will be there. So daily load. Daily load tables are fact tables. Rarely load tables are. So if you go to any business company, any organization, warehouse and product, you see dimension tables rarely loaded, but fact table load is daily. Once the business complete, Walmart, once the business complete, data goes to fact table. Big Bazaar, once the business complete, data goes to fact table. Compulsory daily, sir, daily. You are not finding, but your analysis is on dimension fact analysis only. Next step, daily load, and come to this. For example, but there is small difference if you based on the company you work on. Example, you're working with Airtel, Vodafone, and Idea. Their warehouse level fact table change will be there, along with the dimension change also there. Customer dimension, take customer dimension. Daily new customers will be there, and daily some customers they stop their services also. So new customers or old customers stopping. The dimension table load is regular load. Dimension table load is regular. So product manufacturing companies rare load, dimension load, fact table daily, and these kind of telecommunication customers regular load. Why? Daily customers, new customers added, some customers removed. Right. So where do we have more data? Fact table, dimension table. Fact table, dimension table. Why? Daily business data. That is why we'll keep proper name to the fact table. You are maintaining sales data, sales fact. Manufacturing data, manufacturing fact. And some other, so from example, sales, manufacturing, and work in progress data. Work in progress fact. WIP fact. And ledger data you're maintaining. Ledger fact. So based on the fact table, we'll identify the business, not based on the dimensions. All the dimensions are master tables. Clear? And OLTP containing textual data, so not OLTP. Dimension contain textual data, so it will answer for what, where, when, etc. What about fact table? How much? How many? How much? How many? Numerical data. And real time level, compared to this, we use fact table a lot. Because on this table only we perform aggregate operations, analytical operations, and reports also generated on the fact table. Reports also generated on the fact table. Are you clear? And one more small point. Dimension table has textual data, so it supports hierarchies. Within the country state, within the state district, possible. Fact table level, you can't create. Why? Numerical data. When you expand 10, appearing 20. When expanding 20, appearing 30. Not meaningful. So fact table level, we never create hierarchies. Dimension level, we create hierarchies. And one more. Fact table level, we create KPIs, key performance indicators. So this is a sales value. You got benefit. You want to show red color, so green color, a laughing face. So based on the value, you want to show laughing face. Based on the value, you want to show the color. Then go for KPIs, key performance indicator, important business value show images. Possible only on the fact table, only on the fact table. And along with that calculations, you want to implement calculations. Dimension table is not suitable, only fact table. You want to split the data for easy understanding processing. That is called partitioning. Partitioning also possible only on the fact table. So KPI, calculation, partitions, all possible only on the fact table. And dimension table are only hierarchies. So these are the various differences between dimension and fact tables. Dimension. Are you okay? Right. Any questions? Shall I ask? Okay. Wait for a few minutes, I will ask at the end of the session. So data model decision, when do we go for it? So what is dimension? What type of structure it has? Example, time dimension data. Here in this. I mentioned dimension features. Fact table. What are the features we have? See explanation. Next one. So look at this picture. What is the heading of this? No heading. Guys, whatever the measures you're finding here, see the measures. Measure 1, measure 2, measure 3. Multiple measures you have in the fact table. Look at this, guys. Multiple measures you have in the fact table. Not all measures are equivalent level. This measure may be a normal standard measure, actual cost of a product, estimated cost of a product. This measure may be sum of actual cost, sum of estimated cost. And this measure may be the difference between these two, or the sales growth ratio here. Sales growth ratio. So different measures with different purposes and operations. So these are called as types of facts. Types of facts. The first one is fully additive measure, fully additive fact. That means this will reference all the dimensions and places. In a particular location, from an organization, a product is sold in a time, that value you are maintaining here. So if a measure referencing all dimensions, that is called fully additive measure. If a measure referencing only few dimensions, that is called semi-additive measure. And measure which is not referencing dimension, but still it has values from the existing measures. Those are called non-additive measure. Which measures? Fully additive, semi-additive, non-additive. Fully additive, semi-additive, non-additive. Got it? 3 types of measures I mentioned here. And I want to show you one important picture. So look at this picture. This is organization table, organization data, primary key. Product table, product data, primary key. Location table, location data, primary key. Time table, time data, primary key. Sales table, sales data, primary key. Now 5 table, 5 keys. 1, 2, 3, 4, 5. Rest of the part is measurable part. Correct? Fact table 2 sections. What is foreign key section? Second one, measurable section. Pretty good. And this fact table has one additional column. If you look at this, the dimension tables have one additional column. Look at this. What do you call this? These are called surrogate keys. Which keys? And surrogate key is not a database key. Database level only 3 keys: primary key, unique key, foreign key. But surrogate key is a key which we use in the business intelligence level to take unique values in the column. So some people call it as B key. Some people call it as business intelligence key, BI key. Some people call it as data warehouse key. Data warehouse key, BI key, BE key, surrogate key, all indicate same. It's a key generated by us to recognize records uniquely. Recognize records uniquely. And there is a presence of it. Take this is a location table. Every time Hyderabad changing. So if this is changing, primary key changing, you need to change here also. Correct? Whereas if you maintain surrogate key here, SK underscore location H01 and HM01. Surrogate key values are unique 0.1 created by user 0.2. Third one, non-changeable values. Non-changeable. So rather than HYD, take H01 surrogate key value. Although there is a change to this from HY to HX something, no need to change here because surrogate key reference. Surrogate key values, user created values, unique values. Point number 3, no change. Can you tell me surrogate key features? No change. So helps you to recognize record uniquely here. Point 1. Second one, helps you natural primary key changes in the fact table. Natural primary key changes in the fact table. If 10 times it is changing, 10 times you need to change in the fact table. It's a complex process. Loading data makes sense, but changing dimension, changing fact table, not good at all. So we prefer surrogate keys. Got it? Right. Now come to the next one. The relationship between tables. What is the first one? Star schema means fact table surrounded by dimensions, fact table like this. And these dimensions do not contain sub-dimensions. Whereas Snowflake, fact table surrounded by dimensions contain sub-dimensions. And this less tables here, more tables. And since it is having sub-dimensions close to normalized, not exactly normalized, close to normalized. And this is close to denormalized. Assume product, subproduct, product category, 3 tables available. Which one is the master table? Product category is the master table always, which has product subcategory, which has product information. So this is the lowest level table, low grain table. So master, child, this. So this kind of hierarchy maintained in the Snowflake. And star schema level, all the 3 information is single area. When you load a record, product ID, category ID, subcategory ID, product ID, sales value. So more data. But the advantage is less joins, less tables, less joins. So you'll get the data faster. So star schema only recommended in the real time. Star schema advantage, less tables and more data in denormalized fashion. So that is good for warehousing analysis. Interview question, why star schema is recommended for warehousing projects? Because denormalized data and less joins to retrieve it. Warehouse level, you always bother about less joins. Fast retrieval. So 2 things, you always prefer less tables and more indexes. Less tables and more indexes will help you to retrieve the data more fast. You have a book of 100 pages, no index to it. So reading the book is very tough. If you keep index, easy. So adding index to your book, however, simplifies our reading. The same way adding index to columns in the table to read the respective column data faster or the table data faster. Got it? Great. Now Snowflake schema, fact table surrounded by dimensions having hierarchy. And this is a normalized structure. More tables, less memory, partially follows. What about Galaxy schema? See, there is a specific look, star look. There is a specific look, star, small flake. But there is no particular look. This is called Galaxy. It technically multiple fact table sharing common dimensions. Multiple fact table sharing. And what do you call it? Galaxy schema. Which schema? Galaxy schema. Are you okay? Right. Next. There are dimension types. Fact types I told you, no dimension types. Exactly 10 minutes, I'm stopping the session. Please have patience. Dimensions surrounding the fact, right? And the dimensions also multiple types. First one, confirmed. Confirmed means the dimension which is shareable across multiple fact tables. If a dimension is used by multiple fact tables, that is called as confirmed or shareable dimension. What about junk? If we usually dimension store a particular business information, product table, date table, location table. Sometimes we'll maintain non-business data tables. Example, currency and code. What kind of business it is doing? INR, Indian rupee, some Singapore dollar, something, currency, US dollar, UK pound. It's not doing any business, but still we refer it. That is called junk. That is when we go out in the evening, our parents will say, don't eat any junk food and come. It's a food which helps to fill our stomach, but not healthy, not carbohydrated, not proteinized. So healthy dimension, junk dimension. But still junk dimension usage is there sometimes. And degenerated dimension, the last one. What is degenerated? There could be some situations where you find in the fact table, along with the dimension reference and measures, some more columns. Those are called degenerated columns. Which columns? The column neither dimension nor fact is degenerated. A column dimension column kinda raadu and dimension table nunchi raaledu. Alage measure kaadu. Alanti columns ne untaru degenerated. Example istanu, don't worry. So how many dimensions I said? One is next. What is this? What is role playing? Hey, man, yeah. Role playing. What is role playing? The dimension contain multiple keys and multiple not keys, multiple columns and multiple reference to a single fact table. Usually one dimension to one fact table, one reference. But the same dimension giving multiple references to single fact table. So for the first reference, one kind of answer, second reference, one kind of answer it will provide you. So those kind of situations called as role-playing dimension situations. I'll show you also, don't worry. Now, what is dirty dimension? We never entertain dirty dimensions. We don't maintain dirtiness. But it's a concept. If it comes, we need to eliminate it. We need to eliminate it. So see this. Vinay. Where he is right now? And what was his first location? No answer. Because no date, no time, no unique serial value, nothing. How will you recognize which one is first, which one is current? Isn't it? So these kind of situations are called dirty situations. Technically, we speak like this. A particular business key, not primary key. Data warehousing project level, the word primary key usage is very less. In my meaning, this combination is primary key. So usually we call it as business key. If you maintain a primary key on the table, you can't maintain duplicates. If you want duplicate, you should not have primary keys. But it does not mean you don't have a logical primary key. So logical primary keys we will have in the warehousing projects, we call it as business keys. That's a logical word which we took for the understanding. So business keys are logical primary keys. What is business key? Not technical one. Business key is a logical primary key normally. So wherever one is there, it should belong to Vinay. Okay, Vinay customer available 3 locations. So for the same business key, multiple non-keys. If this is key, this is non-key. Same business key, multiple non-keys available, and you're not able to understand it, then it is called dirty dimension. Which dimension? So role playing is one dimension, multiple references in the fact, and dirty table is same business key, multiple non-keys. Got it? And there are few more dimensions. Infer dimension. What is this? And that can also be called late arriving dimension. Example, guys. Today, Airtel announced one offer. But actually, they haven't taken the offer details in the main table. But still, there is sales for the offer. Sales for the, as soon as they announce, definitely sales starts. Sales started, but the product is not available. If you move the value into fact table, it fails because the product is not available, but sales started. Sales, in that situation, you need to consider The operation has inferred area. Which area? Inferred dimension area. So system understands, oh, this dimension value is not available, but still I need to accept. The usual concept is whatever the dimension value is available. For example, 1 to 10 dimension values, fact table will take 1 to 10 only here. It will not take 11. But recently 11 introduced, but not available in this table. But still 11 it has to accept. If that is the case, you need to consider the dimension as inferred dimension, late arriving dimension. Late arriving, this is recently introduced, 9 years back introduced, due to market demand and market situation. As soon as they announcing some offers, sales beginning, and sales data they are loading into fact table. It's failing because no valid reference. But still they have to accept sales, advanced booking, advanced booking. How is it possible? Inferred. Inferred helps you for advanced booking. So many operations. Got it? Right. Shrunken dimension. Come on. So this is basically to drill down the main dimension level into lower, so that you can analyze easily. Example, month level data available, and you want to report daily level. So the month level data, if you drilling down into day level, the dimension is called shrunken dimension. But there is a separate process to implement it. We'll see later. Okay. So total how many dimensions I told you? Role playing, junk, confirmed, degenerated, inferred, shrunken dimension. Is this clear? Great. The next one, dimension types, fact types, and all of it. There are some situations where you don't maintain any facts at all. Any facts at all. Those tables are called factless fact tables. Factless fact table. Fact table without any valid facts. Example, your student data one area, student table. And your classes data one area, classes table. Your professor data in one area, professor table. Your time data in one area, time table. And combinedly, there is a fact table which is storing student, class, professor, time information. Simply your daily attendance. Regularly you are coming to my class and I want to store. That is called event coverage. I want to store event coverage or event recording. How do you do this? Event coverage or event recording, how do you do this? Come on. Normal, from all the tables, pull the information, push here. So and so student, so and so class, so and so professor, so and so time attended. Okay. If you purchase a product, there will be a value. If you sell a product, there is a value. But if you attend a class, what is the value you will get? Time is the value. You are attending class to gain something, some knowledge. Will you be able to capture the knowledge? So there you are recording the event, but you are not capturing fact. You are not capturing. So these kind of tables are called factless fact tables. Which tables? So mostly event coverage tables, event recording table come under factless fact tables. Over. Right. So last couple of minutes I explained about dimension, fact relationships, factless fact table, types of facts, types of dimensions. Now it's a time to wind up. So hardly 5 minutes I will wind up. Go to this diagram. You tell me what type of schemas are those. No. Look at this picture and tell me what type of schemas are those. This is factless fact table example. Which example? Factless. Date table, course table, student table, professor table, room table. All the keys here without any valid facts. So factless fact. What type of schema is this? What about this? Star. What about this? Star, sir. What about this? Star. What about this? See, 4 dimensions, 4 keys, and this is the measurable part. How many measures we have? And what is the measure name? Units. Star. See, star. Customer dimension, design dimension, product, star. 4 keys. This is measurable part. And what do you call this? Degenerated dimension. Which dimension? Maybe surrogate key also. Maybe. What about this? Time, 1. Item, 1 key. Location, see, 1 table, 1 key. 1 dimension table, 1 key. 1 dimension, 1 key. Measurable part is this. This is also star. This is also star. Date has month, so year has month, month has date, date has date column. Country has state, state has city, city has store data. So this is called snowflake schema. Which schema? Snowflake. Simply dimension having hierarchy. Dimensions having hierarchies. Ankush, clear? This is superstar, mini dimension, single fact. Multiple fact table, dimensions. And no particular look. Star level we have a look, but here no galaxy. This is confirmed dimension because shareable. And if you look at this hierarchy, can tell me from this which one is master, which one is child? Country is the master, supplier is the child. Country is the master, supplier is the child. And always child is connected to fact table. Always child is connected to fact table. This one, snowflake. The product category, subcategory, product, and fact tables. See, foreign keys, measurable part, and this is called as surrogate key. Which key? Snowflake. Fact constellation. What is fact constellation? Galaxy. Fact constellation or galaxy both are same. Multiple fact tables. Sales fact, shipping fact. Sales information you are storing here for sales analysis. So sales fact. Shipping delivery data for delivery fact table. By seeing the name, you can answer. Oh, this is delivery analysis. Food Bajaj Electronics or Big Bazaar, you purchase an item. It is you want the item to be delivered to your home. Then your purchase information available here, your delivery information available. But both uses that information, common information. Sale, whatever you from which branch you purchased, and what is the item you purchased, and delivery, what is the item you purchased. But location, so which location you took, and delivery level, to which location you want to deliver. If you look at this picture, item used by both, so confirmed dimension. Time used by both, green color, confirmed dimension. But location, it has 2 keys in this shipping table. Because while delivery, it will identify pickup location and delivery location. So these tables are called role-playing tables. Which tables? Are you clear? 1 dimension table, multiple foreign keys. Each key giving different information depending on the situation. From means from, to means to. So what do you call this? Role-playing table. Now, cube. What is cube? This is the last one. Cube is multi-dimension holder. Product data here, date data here, country data here. Product, date, country. And these are the cell values. Here is the place your fact measurable values will keep. As your example, first quarter date TV value 100. Second quarter, first quarter PC value 200. First quarter VCR value 100. And TV second quarter sales 200. TV third quarter sales 100. TV fourth quarter sales 100. Now coming to sum, what is the total value? TV all quarter sales is 500. And first quarter all product sales is 400. First quarter all product sales is 400. So cube advantage, cube cells hold measurable values, corner cell hold aggregate values, corner cell hold aggregate values. It will support multiple dimensions. Point 1, multiple dimensions. Point 2, Hmm. This is the value 100, 200. These are called cells. 300, 100. Now altogether 70. 100, 200, 100. So these are the key features of cube. First one, multiple dimensions. Second one, cell hole. Next one, corner cell hole, aggregate values. Are you okay? So that your analysis will be easier. For example, first quarter all product sales. First quarter all product sales is this. TV all quarter sales. TV all quarter sales is this. All product, all dates, all countries, all time sales. This is the value. Like this, it will help you. Got it? Why we prefer cube? This is a cube. If you look at this, heart diseases, age group wise, locations. So here, location, age group wise, how many? A3 age group 97, number of heart diseases this. And if you look at this, 160 in Chicago, location wise. This is time and age group wise, and location wise this. If you add location like this, and there could be something here that corresponding. This is called multi-dimensional analysis. Which analysis? All of you over this. Now it's a time to discuss the FAQs of data model. In this material, you have fully additive, semi-additive, non-additive, factless, fact table. The same diagrams, whatever I explained, all I kept here. You can go through this. So look at these questions first. See guys. So data model implemented basically what are the topic I explained. Those implemented at warehouse level and cube level. Warehouse level and see this cube level star schema, snowflake schema not implemented. Now, first question, what the question? Second question. And how do you differentiate whether a field is textual or measurable? How many types of data models available? Denormalization model, what it is? Relationships. And what is dimension, explain dimension table features? What is fact and explain fact table features? What is surrogate key and where do we use it? What kind of relationship we can establish in dimension model? How many types of dimensions available? How many types of facts available? What is factless fact table? What is cube and explain? Which model you are using in the project? They will ask you. Next, does or which model supports which analysis services? Model support many to many relationship. Multidimensional model. And how? By using intermediate table or bridge table. For more information, refer to SSAS material. Next, usually how many dimensions come to fact table? Next question, on what basis you identify business analysis? And tell me the tables order of load. This is important, concentrate. You got some tables, guys. You got some tables. And they asked you to load it, dimension fact tables. Which table you load first? Always master dimension first. And then child dimension. Finally, you need to load. And master dimension load is direct load. This is important. No problem, directly we load it. And child dimension load is because it is from the parent. So verify against parent. So and so child available in the parent are not, verify and load it. What about fact table? We never load fact table directly. Remember, it is referencing master dimensions or child dimensions. So always validate against dimensions and load. So this part, if you understand, you can happily work with dimension model. Master dimension first, child dimension next, fact table next. Master dimension straight away load, child dimension, and this one fact loading. Okay, next question. Which tables data change frequently and tell me load process in real time? Fact tables data change in real time. Are you okay? So this is how the dimension modeling concept goes. If you have any question, feel free to ask me.